Good morning, students. Today we will learn semantic web. What is a semantic web? What is the need of semantic web? What was there before it? Semantic web is an extension to traditional web. The web prior to semantic web is known as traditional web. In the traditional web, there was no concept of meaning. Meaning is not of significant use. Just it is about the text, what the syntax or the words, but not the meaning. With the advent of a semantic web, which is an extension to traditional web, meaning or semantics have been added to the web. Samina, am I audible?
Hello.
Hello.
Yes, ma'am, you're audible.
Okay. Semantic web would add meaning to the traditional web and provides a common framework that allows to share the data and reuse it across different platforms. It has been developed by W3C, means World Wide Web Consortium, uh, along with the W3C. There were a large number of other participants, including researchers and industrial partners. Semantic web is about common formats for interchange of data and language. Semantic web technologies include XML, XML schema, RDF, RDF schema, and web ontology language. Please remember, semantic web comprises of XML. What is XML? Well, an XML is a general purpose specification for creating custom markup language, similar to HTML. However, in HTML there is no concept of creating tags, user-defined tags, whereas HTML supports user-defined tags, which would add meaning to the document. HTML, all the tags are predefined, and a document is created only from those predefined tags without any explicit or specific meaning with respect to the document. XML, on the other hand, specify user defined tags, and that enables to create a document which is more semantically rich. And XML is designed to be self descriptive. It is classified as an extensible language because it allows its users to define their own elements. All right. Elements could be defined by the user before using those elements. For instance, this is a XML representation for a circular that has been sent from the head of the department. Let us suppose. Circular is the name of the tag that has been created by the user. To faculty from head. This to tag from tag, these are not predefined tags. These have been uh, developed and implemented by the user. Heading is the faculty meeting. The body of this includes there is a meeting of the faculty in committee room on 12/6/2K8. This is the body of uh, the document. And closing of the circular, which is the main tag. Here, apparently, circular is the name itself is quite descriptive, and sender and receiver is also known from the representation. It is very well understood from uh, this these tags that have been created along with the uh, text that have been associated with these tags. That this is a circular which has a meaning from the head to the faculty. Is it clear? This is XML. Essentially, XML is adding some kind of semantics or meaning to the document. This example demonstrate XML representation for a book. A book will have a title, an author, abstract, publisher. Within publisher, there is a name, an address, and closing of the book tag. From these user-defined tags, it is understood that this main tag, the outermost tag, is going to define a book whose title is specified within the title tag. Author is mentioned in within author tag, abstract, and publisher. If you define the same book through HTML, we will not find these kind of specific tags. There is an XML schema. XML schema is used to uh, provide details about the structure. What is the structure of a book XML representation? This book XML representation will have title, will have author, abstract, publisher, and so on. These individual elements have been specified, described in detail, stating that XS XS is a XML schema whose element name is title and which is expecting a value of type string. Likewise, there is another element with a name author, having a string as its type. Like that, you can go on describing every element from this abstract. Publisher is a tag which further includes two subtags. That the structure description could be done in XML through XML schema. All right, this is the first method for a semantic web. We can observe here that we are adding a meaning. What kind of meaning are we adding? Semantics means meaning. These tags are specifically designed for a particular representation. These are not general purpose tags. You don't use these tags for any object. You use this only for book object. Therefore, here some kind of meaning has been associated. That's why XML is included in semantic web, which is an extension of the traditional web. In traditional web, there was only HTML, and HTML does not have meaning. It has predefined tags, and it is used to create any kind of document with those general purpose tags. Second kind of uh, semantic web includes resource description framework. What is resource description framework and what is the need of this? It is primarily used to describe the uniform resource identifiers. It is about having an identifier for every resource that is available on the internet through URI. You might have learned about URL. URL is Uniform Resource Locator. URL includes the domain name and uh, a folder or a directory and the file name. That is a URL. URI is a superset. This URI includes the subject, the relation, and the object. The subject in this triple structure, this structure is known as a triple structure. This triple structure is the URI of some resource. What might be the resource? It might be a system. It might be a router. It might be a mobile device that is connected. Any device that is connected to the internet is described by using URI. URI represents data in triple structure. Triple structure includes the subject. Subject in triple structure is the URI of the some resource. It could be any resource. You take a laptop. The predicate is represented by an URI that expresses some relationship between subject and object. And object is any other resource represented by URI. Let us take an example. If there are two computers that are connected on the internet, these two are connected by means of semantic web, the extension to the traditional web. There is an object, there is a subject, and there is a relation. Let us say this first object is a server. Another second one is the subject is the client. So what is the relation between the client server relation? This kind of specific details related to every resource that is available on the web could be done by using uniform resource identifier. It's a data model for referring objects and resources and their relationships. And their relationship could be expressed and represented in the form of XML syntax. Example, the subject is this URL, which is http colon slash slash www.csc.xuniv.ac.in slash distilled Chris. What is the predicate of the word the creator? And what is the object of the phrase Chris? Chris is the creator. Subject is a particular website or web page, and the creator of that web page is the Chris. So the object is Chris, the subject is the URL of the web page, and what would be corresponding RDF? Uh, Here, what we learned that RDF, Resource Description Framework, comprises of a triplet. Okay, Resource Description Framework comprises of a triplet. Triplet has got subject, relation, and object. What is subject? This URL is the subject. What is the relation? Relation is that Chris is the creator of this subject. Chris is what the object. What is object? Object is the creator. And totally this triplet specify the RDF. We can have such a relation between any two resources that are available. It may include even the persons that are creating the resources. It's not only about the physical hardware. Physical hardware uh, is important part of web where they they connect the components, users, and various documents, resources. On top of those physical components, we find the software components and users who create those softwares. And it is not restricted only to have a relation between the hardware components. We can have between software, hardware, software, user, another user, two machines, any resource which is available on the web. So this is describing all that. And then there is a concept of ontology. Ontology is a specification of a conceptualization for the objects, concepts, and other entities in a domain of interest and relationship that hold among them. If you remember in biology, when we learned about plants, we study their taxonomy. Okay, so there is a family, there is a subfamily, and this belongs to that. Even in animal world, we have this kind of taxonomy.
Classification, madam.
Yeah, exactly. It is a classification. Very appropriate word. Classification. So when you have different resources, different components, elements, all that are available in a particular domain, uh, how to classify them, how to establish a hierarchical relationship. In hierarchical relationship, we will have a superclass, and then that superclass would lead to subclasses. Subclasses might further lead to subclasses, and eventually you might have an instance like that. you will have a hierarchical relationship, which is nothing but an ontology. This is a specific term which is used with respect to semantic web, like we use taxonomy or classification uh, uh, when we are referring to specific problem domain. When we refer to the semantic web, we call such a relationship as ontology. Let us look at an example. This is an ontology of a educational institute. In an educational institute, the institute is the topmost element. Within this institute, there are several uh, departments or units. We can find administration to be one unit, academics to be another unit. Uh, there are some departments like CSE department. Uh, there is a library. Further, under administration, there would be directors, deans, chairpersons of the various bodies. These, these components which have been put together in the form of hierarchical relationship at different levels is known as an ontology. What is the need of ontology? We are learning semantic web. What is semantic web? Well, it is about adding meaning to the web. Although this had already been done a long ago, we are learning now, but it is already done. When the web that we use is totally a semantic web. Earlier, 20 years ago, when there was no concept of meaning or semantics associated with the documents, and also the search engines used to search um, the keywords based on the term matching, not the meaning matching. If you search for Nizam College, what does it do? It searches for that phrase, Nizam College. If it matches in any document, it would return. But now the search engines are uh, essentially intelligent. They understand. They understand the meaning. They understand in what context it is used, why it is used. Uh, so the present web is an intelligent web having semantics, having even artificial intelligence associated with it. Whenever you develop a website, whenever you develop any educational institution resource, earlier, 2 decades ago, it was all about having some elements that are available individually. But then semantic web added this kind of structure to it. And the next concept under semantic web is web ontology language, which is further within ontology. Okay. In ontology, we are learning how to represent the structure, and also this OWL would describe the structure. This is a graphical representation. But again, graphical representation would not be directly understood by the system. This has to be uh, coded or represented in a way that could be understood by the system. For that purpose, there is a language which is known as Web Ontology Language, OWL. This Web Ontology Language was released by W3C World Wide Web Consortium in 2K4. See, in 2004, this was released, which was used to publish and share ontologies supporting advanced web search. When search is done for particular department, uh, let us say CSE students have been searched. In this ontology of IIT Delhi, in IIT Delhi, this CSE students have been searched. When search engine knows about the ontology, search engine could easily traverse to this location and then would return the details of those CSE students. If such a hierarchy does not exist, CSE students might be scattered, they might be distributed, but you are grouping them together under CSE people, which is under main CSE department, which is within an educational institute, for instance, IIT Delhi. Things have been uh, organized and meticulously presented with some kind of meaning or semantics associated. Here, CSC faculty Chris would describe that it belongs to the CSE faculty or resource represents object of type faculty. Chris is a resource that is representing an object of type faculty. Here, this example says that uh, someone with the name Chris has been searched, who is a CSE faculty in a particular institute. All right. There are two ways of developing ontology: either hand code the graphical structure of ontology in a language such as OWL. You have to look at this graphical structure. First, you come up with the graphical structure of these resources, and then by looking at uh, this graphical structure by hand, you write the code. And then another way of doing it is using some standard tool. When the graph is given, when the diagram is given to the tool automatically generate that structure along with the details and description of uh, every resource that is described within the graphical structure. Example is Protige tool. This Protige tool helps in creating all format of the ontology structure. Example is our ontology scheme. There is a student class. Attributes are name, birth date, email. Type of name is string, type of birth date is date, type of email is string. Every resource are using RDF. Every resource is described RDF. Within RDF, we have OWL. In this OWL, it says that data type property. Data type property is this name for the name attribute. What is the domain? Domain is the student class. Why? Because this representation is all about students. It's not about faculty or any other resource. This is student class. So this name belongs to student class. That is shown here. The class of this name property is student class. You open the domain and close the domain. Then there is this range. Range means what values this name could hold. This name could hold string values, which is the type of the name. The second property is birth date. Birth date property or attribute. Domain is student domain, student class domain. and range is date. Another one is email. This email domain, uh, actually email is a property of domain student and its range is string. This is how this particular uh, class, which is a student class, which is a part of the ontology, is described using RDF and OWL. OWL document consists of ontology headers, any number of class axioms, property axioms, facts about individuals, and OWL does not impose any ordering. You can describe any property in any order. And the extension of this entire file is .rdf or .owl. Owl representation of ontology. This one would describe the entire uh, hierarchy, which is referred by educational institute. The main figure. In the main figure, we have got various classes: administration class, academics class, CSC, library, and within administration, we have got directors, deans, all these entire structure now has been coded. Okay, this is all about um, semantic web. Students, any doubts in this semantic webs? If no, let us move ahead with the new topic, which is natural language processing. This is the last topic of Unit 5, and this week we will finish this topic and all the subtopics within this so that you are ready to face your internals next week. Uh, Also, I think next week is your last week in this semester. Students, please let me know if you have any doubts. I have uploaded all the videos of all the classes that I have taken in this semester. I'll share the link. Already it is there with you, but the link of playlist I will share. If you get any doubt, you can ask in any of the class in this week. So NLP is the next topic. NLP is natural language processing. What is a natural language? A natural language is a language spoken and written by humans. Language of humans is a natural language. Language of computers um, is a programming language. Computers understand directly machine level language. When you use any programming language, it is directly translated into machine language and computers understand. Uh, Apparently, as we are growing and developing more and more technology uh, with respect to computers and computer science, artificial intelligence, robotics, and all, there is a need of uh, having computers knowing the natural languages. When computers are programmed using programming languages, it is required for a human to learn a programming language. But then, as we uh, advances, we want computers to behave more like humans. We don't want computers to be like a device which has a specific syntax, format, semantic that we have to learn in order to communicate with it. Why should we learn its languages? It should learn our languages. That is the whole idea. And then, if machines start learning humans' languages, there are enormous number of benefits. A person who is totally, void of any language or any knowledge or any education. As a matter of fact, if a person does not know anything, does not understand anything related to computers or related to technology, even he can operate a technological device if the device understands his language. Suppose in rural areas, there are people who know their own vernacular language, which is a mother tongue. They know only their mother tongue. They don't know anything else. And that too, they cannot write it. They cannot read it. They can just talk in it and they can just orally understand it. That person could also use a mobile device or a laptop if that device could orally speak uh, the responses for the questions which he posed in his language. You imagine how much development we can achieve and how useful it is. Because of this, even the farmers who don't know anything about technology can use the technology to understand about the soil, understand about the seeds, understand about the plants, understand about plant diseases. There are so many benefits uh, if devices learn natural language. This chapter deals uh, all the technicalities and specifics about how to make a machine learn natural language. It is actually an area of AI. Why it is an area of AI? Well, AI is all about making machines behave in a human uh, manner. How humans behave, machine should behave in a similar manner. That's why it is a part of AI. And it should understand natural language, it should generate natural language, it should respond to the queries posed in a natural language, it should frame sentences in a natural language. It should understand the intricacies of a language, it should understand the proverbs in a language, it should understand the sarcasm in a language, it should understand every detail how we humans understand. This language understanding is not an easy task. It has to go through several phases uh, in order to be uh, clear with the message that has been communicated by the human. Basically, NLP involves processing of written text. NLP is about written text, whereas NLU is about um, oral text, or not text, oral speech, means understanding speech. If suppose I say, uh, uh, hey hey Google, if I say hey Google, it is not written, it is oral. And suppose if I write uh, some phrase in a Google search engine, then that is uh, written natural language. So the system should understand both written, and NLP deals with written. It involves lexical analysis, syntactic analysis, semantic analysis. Um, Also, it should be able to process a spoken language. Sentence analysis phase. A sentence is analyzed through different phases. Suppose a sentence is given to the system. Um, I say uh, book a movie ticket. Suppose there is a sentence, book a movie ticket on this date for this movie, on date, a specified date for particular movie, at which theater. This sentence is, you know, you have written this sentence in your assistant interface. You have an assistant, means automated assistant, not a human assistant, a machine assistant. To that machine assistant, you write this text and say submit. To understand this, that system, AI system would have to follow different phases. What are the different phases? First one is morphological analysis. Second one is syntactic analysis. What is morphological analysis? Well, it is about uh, understanding the uh, words, a root word, understanding the root word by eliminating the suffixes and prefixes. If here example given is pushing. Suppose pushing word is being used. Pushing is not a root word. There is ing suffix attached to it. What is the root word to this? The root word is push. Okay, so uh, when a system uh, learns the or extracts the root word from different words, then it is all about morphological analysis. Syntactic analysis is understanding the grammatical rules. Uh, uh, bring or suppose there is a sentence. Here the sentence is okay, consider book a movie ticket. This is a subject, there is a predicate, subject, verb, adjective. Like this, there is a format, grammatical format. That using that format only sentences are framed. Uh, for instance, John, John is giving chocolate to Tom. So what is this? This is, there is a subject, there is an object, there is a verb, and there is a format. To understand the sentence, it has to be parsed. Parsed means we have to come up with the tree or any form, any specific representation that states what is John, whether John is the subject or John is the object, John is the noun or John is the verb. What is it? And then uh, giving means what? It's not means exactly. It is grammar. Knowing the grammar structure of the sentence, not the meaning. First, if we know the structure, only then we can know the meaning. We can derive the meaning from it. If structure is not clear, then meaning cannot be comprehended. So syntactic analysis is all about coming up with the structure or parts, which is known as a parse structure, and the process is known as parsing. Next important phase is semantic analysis. Semantic analysis is about describing the meaning of each term or a word in the parse structure. Okay, then when there is a parse structure, uh, next step is knowing the meaning. Who is doing what and what is happening in that. The main purpose of semantic processing is the creation of target representation of the meaning of the sentence. All right, here meaning is important. Let us take an example again for these two. If you put giving before John, then that parts tree will can't be created, because you cannot have a verb as the beginner of a sentence. You cannot begin a sentence with a verb. Then parts tree is not proper, means syntax is not right. If syntax is not right, you cannot come up with a right parts tree. But suppose now the parts tree has been generated properly, then the next task is to know what is John doing to Tom, and by uh, going through the meaning of every word, this giving, you obtain the root word of this giving by using this morphological analysis uh, to the word give. And then give is what, a verb, and verb give means something is given. So what is that something? Now that something is chocolate, like that meaning is derived. All right, after that, after these three phases, the next phase is pragmatic analysis. Pragmatic analysis is the advanced phase that is used to interpret the sentence based on different contexts. For instance, John saw Mike in the garden with the cat. There are two interpretations. The first interpretation is John was having cat and saw Mike in the garden. This is first interpretation. The second interpretation is John saw Mike with a cat in the garden. Okay, here John is seeing a person named Mike. Mike has a cat, and Mike and cat both are in the garden. Based on the context, the interpretation would change. And pragmatic analysis is all about coming up with the right interpretation. John was having cat and saw Mike in the garden. This is also one way of interpreting. Which one is right? Because we humans know about different aspects. We know about say that that cat is Mike's cat. Suppose I we both know that cat is Mike's cat. Then what interpretation we will derive? We will know that because that cat belongs to Mike, John is seeing Mike and cat in the garden. All right, because we have got some prior knowledge, prior information with respect to Mike and cat, but system will not have. Discourse analysis refers to conversation between two or more individuals and interpretation based on the belief at the time of the conversation. Based on the conversation, example is, mm, uh, there is a mother and there is a son. This son is going to school, at suppose at 8 o'clock. Son is getting ready and son says to mother, I am not finding my shoes. Then what mother would do? Mother would understand that son needs the shoes to wear to go to school. So mother look for the shoes and bring uh, those to the son. Then son wears. Just a sentence like I am not finding the shoes will give the uh, complete picture to the mother that son needs the shoes to wear and go to school. But if this sentence is given to a machine, I am not finding my shoes, then what machine will understand? What is the direct or literal meaning of that? That that person is not able to see where the shoes are in his room or wherever. but it's not that it's not that simple. It's not very straight away uh, sentence. It is having some meaning with respect to the time, with respect to who is speaking and who is listening. So incorporating all these things in a machine is quite a big task and very complex and complicated task. Okay. We will learn these grammars and parsers tomorrow because it's a new topic. Then we will learn. We will begin tomorrow. Any doubts, students, in all this? If there are no doubts, please wait. Let me take the attendance. Yes. Anything to discuss? Rule number 3, 24, 28, 47, 49, 50. All right, students. See you tomorrow.